4345. What CAS must be used to maintain a filed TAS of 128 knots at 5,000 feet MSL if the outside air temperature is plus 5 degrees Celsius? A. 119 KCAS. B. 124 KCAS. C. 126 KCAS. The correct answer is A. When TAS is known, the correct OAT and pressure altitude are needed to determine the CAS. Substitute the uncorrected OAT and the scheduled flight altitude since neither are available for the issue. Determine the CAS using a flight computer using the provided data. Airspeed on FLT menu using a CXS. Position, 5,000 feet. Temperature, plus 5 degrees Celsius TAS. Wind speed, 128 knots. CAS is therefore 118.9 KCAS. 4359. What CAS must be used to maintain a filed TAS of 160 knots at 11,000 feet MSL if the outside air temperature is plus 5 degrees Celsius? A. 129 KCAS. B. 133 KCAS. C. 139 KCAS. The correct answer is B. To calculate the calibrated airspeed, CAS, required to maintain a specified true airspeed, TAS, at a given altitude and outside air temperature, we can use the following formula. CAS equals TAS multiplied by 1 plus 0.2 multiplied by OAT, ISA, by ISA. Use code with caution. Learn more. Where CAS equals calibrated airspeed in knots. TAS equals true airspeed in knots. OAT equals outside air temperature in degrees Celsius. ISA equals international standard atmosphere. In this case, we have TAS equals 160 knots. OAT equals plus 5 degrees Celsius. ISA equals minus 5 degrees Celsius. Plugging these values into the formula, we get CAS equals 160 multiplied by 1 plus 0.2 multiplied by plus 5 degrees Celsius minus 5 degrees Celsius by minus 5 degrees Celsius equals 133 KCAS. Use code with caution. Learn more. Therefore, the CAS required to maintain a TAS of 160 knots at 11,000 feet MSL if the outside air temperature is plus 5 degrees Celsius is 133 KCAS. 4323. What CAS must be used to maintain a filed TAS of 110 knots at 7,000 feet MSL if the outside air temperature is plus 5 degrees Celsius? A. 98 KCAS. B. 101 KCAS. C. 103 KCAS. The correct answer is A. To find CAS when TAS is known, the correct OAT and the pressure altitude are required. Since neither are available for the problem, substitute the uncorrected OAT and the planned flight altitude. Using a flight computer, determine the CAS from the given information. Airspeed on FLT menu using a CXS. Altitude, 7,000 feet. Temperature, plus 5 degrees Celsius. TAS, 110 knots. Therefore, CAS is 98.4 KCAS. 4089. Under what condition is pressure altitude and density altitude the same value? A. At standard temperature. B. When the altimeter setting is 29.92 inches of Hg. C. When indicated pressure altitudes are the same value on the altimeter. The correct answer is A. Pressure altitude is the altitude indicated when the altimeter is set to the standard atmospheric pressure setting of 29.92 inches of mercury, Hg. It is a measure of an aircraft's height above the standard pressure level. Density altitude, on the other hand, is a calculated altitude that takes into account the effects of temperature on air density. It represents the altitude at which the air density is equivalent to the air density at the current pressure altitude. When the temperature is standard, meaning it matches the standard temperature for a given pressure altitude, the pressure altitude and density altitude will be the same value. This occurs when the atmospheric conditions adhere to the International Standard Atmosphere (ISA) model, which defines standard temperature lapse rates at various altitudes. 4090. Under which condition will pressure altitude be equal to true altitude? A. When the atmospheric pressure is 29.92 inches of Hg. B. When standard atmospheric conditions exist. C. When indicated altitude is equal to the pressure altitude. The correct answer is B. When standard atmospheric conditions are present at a given altitude, pressure altitude will be equal to real altitude.